Thank you, Lex. Yesterday we started graphing exponential functions. We'll look back at graphs again, but for now we're kind of moving past that. What we're doing is exponential functions are like something like this from yesterday. Y equals something to the power of x. And the whole idea is that this is new to us. Like we haven't seen x in the exponent before. We haven't graphed it before. We haven't solved it before. It's pretty much like brand new territory for us. What we're going to do today is we're going to try to solve equations when x is in the exponent. We're going to have two strategies for that. The first one is called like bases. It's usually the easier one, but it only works in like the perfect situation. So teach Sarah. Here's how like bases work. If you can take a question like this, and first thing I notice is that the x's are in the exponents. Then what I want to try to do is I want to try to make the base of the power the same. In this question, it already is. They're both base 3. See how they have the same base of the power? Beautiful. If you have the same base equal, that means the bases are pretty much irrelevant to us. And all we need to focus on is making the exponents now equal to each other. So I'm going to rewrite this as x plus 1 equals 3x. If the base is already the same, then if I can make the exponents the same, then both powers would be the same. Okay, so I got like bases, get rid of the bases, focus on just the exponents. That should be pretty simple to solve once you get like bases. This is a linear equation. A reminder of what a linear equation is. A linear equation means the highest exponent you have on an x is a 1. Okay, the way we solve linear equations is we move all of our x's to one side of the equal sign and all of our numbers to the other side. We move numbers using algebra. We use opposite operations. So I need to move all my x's from the left side to the right side by subtracting one x from the left side to the right side. Okay, I'm moving my x's all to the same side of the equal sign. On the left-hand side, x minus x would cancel out. I would be left with a positive 1. On the right-hand side, 3x minus 1x, it'll come back. It's just the joys of this television. 3x minus 1x would equal 2x. Just like a reminder, sometimes people screw this up and they do 3x minus x is 3. This is how many x's you have. I have 3 x's and I subtract 1 x. Leaves me with 2 x. Pardon?
I think it's not recording.
It is. Yeah, I still got you. It never stopped recording, except for when I pause it for the stickers. At that point, now that my x's are on one side, I need to move all my numbers to the other side. So I need to get rid of that 2. I need to get it from the right side to the left side. You do opposite operations. 2x means 2 times x. The opposite of times is divide. So I divide that 2 to the other side. 1 divided by 2, you could write it as a fraction, 1 over 2. On the right-hand side, the 2's would cancel out. The answer is 1 over 2 equals x. That means if I took that value for x and I put it back into the very starting equation, these two powers would now equal each other. Makes sense if you try it. This is 0.5. 0.5 plus 1 is 1.5. 3 times 0.5 is 1.5. So these would be the same power. That's called like bases. So solving exponents using like bases. Let's try another one. So looking at this guy. First thing I notice is that the x is in the exponent. I say x is actually an m. The variable, the letter, is in the exponents. That tells me that I want to use my like base strategy if possible. Looking at this question, it already has like bases. This base is 1 over 2. This base is 1 over 2. That means I can focus solely on the exponents, means 2m squared plus m equals 20 minus 2m. Okay with that? Like bases, go on, focus on the exponents. That's our new step. Now we're back to an equation that should be familiar to us. All right, like this should be something I feel like I can solve because the m's are no longer in the exponents. They're just down regular old variables. Problem with this one. This is a quadratic equation. I know it's quadratic because the highest exponent is 2. Okay, this is back to Math 20-1. To solve quadratic equations, you need to get to general form. General form. General form looks like this. Ax squared plus bx plus c equals 0. A lot of you guys haven't solved a quadratic in a year and a half. So I taught a lot of you first semester last year. So it's been a while. Right? If you have exponent 2, it's called a quadratic. You need to move it to general form. So get everything on one side. Ideally, you want your a value to be positive. So in this case, this will be my a value. So I want everything to move to the left in this question. Because I want a positive a value. We move things by doing opposite operations. I'm going to move the 2m by adding 2m to both sides. I'm also going to move the 20 by subtracting 20 to both sides. That gives me, on the left-hand side, 2m squared plus 3m minus 20 equals 0. Right, the right-hand side, everything canceled out. That didn't look like too much magic. All right. Then you got to solve this thing. Okay, you have multiple strategies to solve this thing. I think that your best option is to factor. Factor means you are taking something and breaking it into multiplication. Our strategy to factor this is diamond method. If that doesn't work, then you can move on to the quad formula. Because the quad formula will always work. Yeah, we'll do diamond and correct method, yeah. Yeah, I think this is the better way to go. People are usually better at factoring than quad formula. Factoring is also algebraic. So you're going to see a lot of questions that will be like algebraically solved. Like then you're algebraically solving it. Instead of just throwing it into a formula. The factor. Again, it's been a while. This is a 3-term polynomial. So our strategy to factor will be diamond method. You draw a diamond. On the top of the diamond is your a value times your c value. So for us, that would be 2 times negative 20, which is negative 40. The bottom of your diamond is your b value. In this case, 3. Your goal is to find 2 numbers for these sides of the diamond that multiply to be negative 40 and add to be 3. Things that multiply to be 40. 40 and 1. Okay, but that doesn't add to be 3. 20 and 2. Doesn't add to be 3. 4 and 10 would not be able to add to be 3. 5 and 8. 5 and 8 could add to be 3 if I had positive 8 and negative 5. I also know that one of them is going to be negative because it multiplied to be negative 40. All right, so that also kind of gives you a bit of a hint. Perfect. Those of you guys who just finished taking Math 30-2 with me, we did not have to factor anything like this. The difference between what we used to factor with diamond method and what we're factoring right now is that there's an a value of 2 right here. And that's going to cause us like a little bit of a problem. So just make sure you make note of that compared to last semester. Cool. All right. I did my diamond. Awesome. I had a rule, if I taught you in Math 10, probably use the same joke in Math 20, is that anytime you factor a trinomial, it turns into 2 binomials. It's one of the 3 guarantees in life, right? Like 3 guarantees of life, death, taxes, and when you factor trinomials, 2 binomials. Yeah, see? Same joke. Works every semester. Okay, so I know this is going to turn into 2 binomials. I also know that this first term always comes from the first terms being multiplied together in that binomial. So that means one of these has to be 2m. Right? One of them has to be 2. The other one has to be 1. You don't know which one's which. So you're going to make both of them 2. It's wrong. That's a mistake, right? We're going to fix that mistake in a minute. The reason it's a mistake is because 2m times 2m would be 4m squared. So we're purposely making an error that we'll fix in a second. That diamond that we just created, that's the second term in each of your binomials. So it's 2m plus 8, 2m minus 5. Now we fix the mistake. To fix the mistake, you look at your binomials. One of them should be able to take a 2 out because there's an extra 2 in here somewhere. This one can get rid of that extra 2. Right? 8 divides by 2, 2 divides by 2. This one, you can't take out that 2. Right? 5 does not divide by 2. That means this was the one that was wrong. When you take that 2 out, you now have m plus 4, 2m minus 5 equals 0. We have not solved yet. We've only factored. I want to make sure that we get questions out of the way on this factoring, though. So if you're looking at that and you're like, ooh, it's been a long time since I factored, Mr. Kennedy. This would be a good time to ask for a little bit of a refresh. Like, where did a number come from? Yes, sir. Yeah, of course. We're all right? Yep. Okay, and that's a really, really, really good point. This 2 is not a GCF, right? So GCFs are when you're like factoring it out. We're not. We're fixing a mistake that I purposely made. So that's why it doesn't go anywhere.
But it's making the 8 forward, so shouldn't it?
It's because I had an extra multiple of 2 all the way back here from the diamond. So like from the very beginning, there was a mistake in the diamond, and there's a mistake in my A value, which is what we're correcting. We just don't usually talk about the mistake in that diamond. The fact that 8 wouldn't actually work. All right. If you're struggling with factoring and you're like, oh, I don't know, and you do questions in your practice booklet and you're like, oh, I definitely don't know how to factor. I got like a million resources on factoring. Okay, so just ask. I can help you. I've got videos. I've got a million questions with answers. Like we can figure out some factoring to help you out. Perfect. We did not solve. We factored. Factoring will help us solve. The way it helps us solve is by using something called the zero product property. It's something you would have learned like a long, long time ago. It's that anything times 0 is 0. right? So for instance, no matter what this brackets were for a number, if I can make this 0, then this equation works. Because anything times 0 would be 0. Same thing works in reverse. If I can make this set of brackets 0, then this set of brackets wouldn't matter. Because 0 times anything would be 0. So to solve this thing, you take each set of brackets and you calculate how could I make that equal 0. It's like you've made two little linear equations. For now, I'm actually going to go through the motion of like setting it up. Once you've done it, you're going to start to like get them really quick, and you're not even going to have to write out the steps probably. But for now, I want to show why these work. So if I look at the orange one, and if I wanted the orange one to be 0, the first set of brackets, I would move this 4 to the other side, and I get my first answer, m equals -4. That would make the first set of brackets 0. To make the second set of brackets 0, got a little bit more work to do. I'd have to move the 5 over by adding 5. Then I'd have 2m equals 5. And then I'd have to divide by 2. Giving me a second answer of m equals 5 over 2. Those are the two answers to this question. That's like a harder level 20-1 solving quadratics question. Like that's pretty challenging. I will try my best, especially early in the semester, to go slow on things like that. We're going to get to a point where we just got to rip through things like that. So you do need to get good at factoring. I know we've lectured you for like 3 years now. Get good at factoring. It's like, this is the year why. All right. Try this guy. Pretending this is a test question. All it says is solve. That's the only word that would be there. Just say solve. First thing I identify, x in the exponent. That's the first thing I look at. I'm like, okay, if the x is in the exponent, I need to get the same base. Luckily for us, we already have the same base. These things are both 9. That means the bases are now irrelevant, and all I need to make equal is the exponents. I have 4x squared minus 9 equals 3x squared. Perfect. I'm still in solve mode. Next thing I identify, this is a quadratic equation. It's quadratic because the highest exponent is 2. That means I need to get to general form. I need to equal 0. So I'm going to subtract 3x squared to the other side so that I have general form. Like that. At this point, ladies, gentlemen, at this point, you do have two options. I prefer to factor. Okay? The reason I prefer to factor is because then I don't screw up and say that the answer is 3, because that's what people always put. This, though, can't be factored with diamond method. This is factored with difference of squares. Right? Difference of squares means that you have subtraction of things that can be square rooted.
Wait, why can't it be done with diamond?
Right? You actually can diamond method it.
I think I just.
And I taught that 1 year. When you diamond method it, you'd be multiplying to be -9 and add to be 0, which is 3 and -3. So diamond method actually does work.
Okay, I did that.
I believe when y'all were in grade 10, we taught you difference of squares though. And I know in grade 11 we taught you difference of squares. So I'm going to stick with that. But if you do diamond method, that's right. Okay, difference of squares. square root. Well, you guys gotta stop talking. Joel. You square root both terms. That gives you x minus 3. Then you get a second binomial. That second binomial is x plus 3. Right? It's called the conjugate. You get one that's opposite. So you get one negative, one positive. Then you do your zero product property. Okay? I prefer to factor because then it just keeps us structured. Yeah.
Wait, how come you can't just move the 9 over and then if you square root it, then it has to be a plus or negative?
You could. The reason I avoid that one, so she's saying move the 9 over.
Yeah.
So it looks like this, which is spot on. And then square root both sides, like that, which is also spot on. People forget to do positive, negative. So they say the square root of 9 is 3. But if you remember, just make sure you do that, and you're good. Yeah, that works perfect. So like I said, this would be the second strategy I talk about. And you could diamond method as well. So like there's more than one way to get there. Sticking with like that middle strategy that we had, you then check what makes each set of brackets equal 0. The first set of brackets, if x equaled 3, it would be 0. 3 minus 3 is 0. Second set of brackets, if x equaled negative 3, negative 3 plus 3 is 0. Also works. So your answer is x equals 3 or negative 3. What Maddie was talking about is move the thing over, square root both sides, and look, you got the exact same answer. X equals positive negative 3. What Cecily was talking about was do diamond method, and you notice that both the sides are 3 and negative 3, so you get the same factors. All three strategies are legit. Beautiful. Okay, now, if every question automatically had like bases to start, that would be fantastic. I don't think you're going to see that probably like ever on a test. It's just too basic. So typically what's going to happen is you're going to get equations where the bases are different. And you have to make them the same. So we're going to talk about how you do that. Let's look at 9 to the power 2x to base 3. I want to take this 9 and change it to be 3 to the power of something. 3 to the power what would be 9? Yeah, 3 to the power 2. So to change this base, it would now look like this. 3 squared to the power of 2x. Not hard, right? You took the 9, you changed it to be 3 squared. Notice that I put brackets around it. Also notice that the 2x did not change. It's still there. You now have what I call power of a power law. I don't think that's the right term. But you have an exponent with an exponent. So we have to use that exponent law that we learned yesterday, which says this thing will multiply in, making this 3 to the power of 4x. Right? We multiply it in. That is called change of base. I took a power that was base 9. I changed it to a power that's base 3. Perfect. Let's see it with fractions. So if I wanted to do this with fractions, it's telling me to change it to base 5 over 7. Looking at this, I could change 25 to base 5 by making it 5 squared. Agreed? Below that, I've got 49. Where did my rating just go? There we go. Below that, I got 49. I could rewrite 49 as 7 squared. I still have the original brackets. I still have an exponent of 3x. And I've now changed this from 25 over 49 to 5 over 7. Once again, though, we have a power of power going on here. Right? I have exponents on the outside. So I'm going to multiply that in. This 3x will go to both things, making it 5 to the power of 6x over 7 to the power of 6x. That's how you would have seen that exponent law done in grade 10. We would have brought that 3x in like that. It's also good to be able to understand you could actually multiply that the other way. Like I could rewrite this as 5 over 7 to the power of 6x. Right? If they both are the same exponent, I could just take that exponent to the front or to the outside. Change a base. Started with 25 over 49, changed it to 5 over 7. All right. This guy. We want to change that thing to become base 4. That's going to be a lot trickier. That's a fraction. And it's like, how am I going to get a fraction to be just a 4? First thing we're going to work with is just this 64. Let's just focus here and see if I can't change 64 to become 4. You can. Right? So if you try it in your calculator, if you're not sure, just guess and check. Go 4 to the power of 2, see what it is. 4 to the power of 3, see what it is. 4 to the power of 4, see what it is. Eventually you'll find that 4 to the power of 3 is 64. Okay, but just like guess and check a little bit. So I can rewrite this to become 1 over 4 to the power of 3 to the power of 2x. I'm too zoomed in and it's making it very messy. Try again. Like that to the power of 2x. See my exponent of exponent? Bring it in, right? So that 2x I'll multiply in. I now have 1 over 3 times 2x would be 4 to the power of 6x. Fantastic. That is not base 4. Okay, the denominator is base 4. But this entire thing is on a power in base 4. So this is not quite there. To get this to become base 4, we're going to do what I alluded to yesterday, and we're going to use our negative exponent law, but backwards. So we learned yesterday that if you had a negative exponent, say like this, you could rewrite that as 1 divided by 2 to the power of 3. Right? That's our negative exponent rule. We're actually going to do it backwards. We're going to create negative exponents to get rid of fractions. So this could go backwards and become 4 to the power of negative 6x. That's now base 4. So I had to get rid of my fraction to make it base 4. That's hard. And that's something you've never seen before, right? Like up until right now, you've always been told get rid of negative exponents. And now we're creating them. We're creating them to get rid of fractions because we want to just base 4. We feeling all right with that? It's okay? Okay, I think we got one more. Yeah. 27 over 64, we want to change it into base 4 and base 3. Okay, again, let's just focus on what we can turn these into for now, and then we'll focus on actually getting it to where it's asked. So if I look at 27, 4 to the power of something is never going to be 27. Right? 4 to the power of 2 is 16. 4 to the power of 3 is 64. Anything bigger than that's a bigger number. But I can change 27 to be 3 to the power of something. So if I tried, I could do 3 to the power of 3. It's in the wrong side, but at least I've got it down to something smaller, away from 27. Same deal with 64. Like 64, I can write smaller. I could rewrite 64 as 4 to the power of 3. And you can see I'm close, right? Like they wanted me to go 4 over 3. I got 3 over 4. I'm close. The outside is still the same. That has not changed. X plus 2. Perfect. Now, let's see if we can't match up with what they have, which is 4 over 3. If I want to move something from the bottom of a fraction to a top of a fraction, what am I going to do? Change the exponent to negative. Perfect. So if I want this to move to the top, it would become 4 to the negative 3. If I wanted the 3 to the power 3 to go to the bottom, it would become 3 to the negative 3. Anytime you move a power, it changes that symbol. So now it looks like this. 4 to the negative 3 over 3 to the negative 3. And now I've matched what they wanted. Now I have 4 over 3. Right? There's that negative exponent trick. If you want to move something, change the exponent. Last thing I'm going to do here, I have a power of a power. Right? I'm going to actually just go outside. So these are both negative 3. So that means I could rewrite this. By multiplying negative 3 out of the brackets, it'd be negative 3x minus 6. And that's if I took this and multiplied it. And then I'm just moving it to the outside, like I did in the previous question. Cool. That one is like excessively hard. Big things to focus on when you come in. I'm sure like you've heard teachers tell you this before. But when you're in a diploma class, like we're preparing you for a diploma exam, right? Which means you're going to get in math like 30 questions you've never seen before. They're going to make up questions that I've not ever seen before. They're not allowed to show me them. They're brand new questions. So focus your energy on learning concepts and not memorizing steps. Right? Like a good concept to learn here is that I can change bases and how negative exponents work. Right? And then in the future, it's like, how can I apply that to different situations? And it's what makes these classes so challenging, especially Math 30-1. You're going to see it probably in Physics 30, for those of you who are in Physics 30, where like you've learned a concept and then you get tested on that concept in a way that you really haven't seen before. And it leaves you with that feeling of like, you didn't teach me this. You know that feeling? You've written a test and you're like, they never even talked about it. They've taught you the concept and they've given you the skills and the strategies to solve whatever's there. Don't get hung up on like, practice questions got to match test questions because it's just not going to go that way. If we did it that way, you get to a diploma exam and you get smoked because it'd be the first time that you're seeing questions that you can't like critically think for. Do you know? Kind of get what I'm saying? So try your best to focus on like strategies and not every single step. It'll help. Cool. That's change of base. Let's try using change of base. So back to what we were doing before. We're solving exponents. All right. Imagine that's a test question. All it says is solve. First thing I identify, x is in the exponent. As soon as I see that, that tells me I want to use change of base. Sorry, I want to use like bases. That's an immediate thought process. Check the bases. These bases are not the same. I have 3 and 27. Not the same. That leads me to attempting change of base. I want to make something clear here. I always find it helps me. When you're doing change of base, always go big to small. What I mean by that is people will look at this and they'll identify 3 to the power 3 is 27. They'll get there. One way or another, they'll be like, okay, 3 to the power 3 is 27. And then what they do is they change this one to be 3 to the power of 3. And you change the small one to become the big one, which is not correct. You want to take the big one and rewrite it as the small one. Okay? Always go big to small. So it should look like this. 3 to the power of 3x plus 1 equals 3 to the power of 3. There's my change of base. I've done it in blue. To the power of 2x. Always go from big number to small number. Don't change the small one to become big. Perfect. I have an exponent with an exponent. Multiply that in. So I now have 3 to the power of 3x plus 1 equals 3 to the power of 6x. And now I have like bases. These things are both base 3. Which means I can get rid of the base and I can focus on making the exponents equal each other. I have 3x plus 1 equals 6x. That is a linear equation, meaning highest exponent is 1. So I'm going to move my x's to the other side, subtract 3x to the other side. I have 1 equals 3x, and then divide by 3. That gives me 1 over 3 equals x. You could, like, as a decimal, it's 0.3 repeated. If it's not a terminating decimal, leave it as a fraction. Okay? If it had been 0.3 and stopped, that's cool. If it's 0 point something repeating, then leave it as a fraction. How are we feeling about that? It's okay? Big to small? All right, beauty. Look at B. First thing I identify. Letters in the exponents. That immediately tells me I want to do like bases. Okay, that tells me that's my strategy. Now, I want to go from big to small. So I start trying to turn 27 into 9 to the power of something. And it doesn't work, right? 9 to the power of 1 is 9. 9 to the power of 2 is 81. 9 to the power of 3 is like 720 something. It gets really big really quick. So I actually can't change 27 to be 9 to the power of something. Which means I'm going to have to change both bases. And they're both going to have to go smaller. If there's one that you know, focus on that one. Like for instance, I know 3 squared is 9. I know that one. Then I can start guessing on the other one. So I know that one. Now I'm just going to start guessing. 3 to the power of 3, is that 27? 3 to the power of 4, is that 27? Guess until you find it. It is 3 to the power of 3. And you see, I found like bases. I made both numbers smaller. I went from big numbers to small numbers.
So do you just look for the lowest common factor?
Yeah, like usually there's one that you can get and one that's hard. Like I know 9 came from 3 squared. So then I just start guessing on 27. Like if I look over here, I have no idea what's gonna. That's a terrible question to look at. I look over here. Like I see like 3, 9, and 81. Like I just find the lowest one, which would be 3, and I'm just gonna find a way to get to 3. I'm just gonna guess and check, right? I mean, like 3 squared is 9. Nope. 3 to the power of 3 is 27. Nope. 3 to the power of 4 is 81. Oh, look, it worked. Like I don't know that, right? I'm just guessing and checking.
But like in case of like 9 and 27, where like 9 times like nothing is the exponent is 27, you would just look for the lowest common thing.
Yeah. Like this. I'll give you a better example. If we had something like this. 8 can't become 4, right? But could you redo 4? Could you rewrite that as something? Right, like that's what I mean. There will be one that sticks out. Go with the lower one usually. Find out what it is. And then try to turn 8 into that same base. Right? Like, I think what you're saying is like, do I want to do the lower one first? Do the lower one first. Like, do the one you know, and then try to find a way to turn that into that.
Okay. Is that the only way to do it? Or couldn't you like square cube root them and just like use the index to cancel out exponents?
No.
That doesn't work like that?
In like the perfect scenario, that would work.
Yeah.
But that's gonna have to be the perfect scenario. It'll be pretty hard pressed to find something like that works out. So I would probably just stick with this. We will get to a point where we can't do like bases, and then we do have another strategy. Okay, I want you to try to solve this one. So go ahead on your own, try to figure out what x equals. Remember that you need to multiply these in first. So I'll give you a minute here. See if you can solve it. I'll start putting the answer up so you can check if you're right or wrong. Of course. It's linear, which is nice, right? I have 10x equals 6x plus 3. Move the 6x over, then move the 4 over. I try my best to always show my algebra in red, like whenever I'm moving. Sometimes I get away from that, but I'll try to color code things if you haven't had me before. Okay, third question. Definitely harder. So if I look at this third question, I'm just going to stop casting for a second here. If I look at that third question, I see that I have base 3, right? Like I see this right here. So like my initial instinct would be to make this 3 to the power of something. That's my instinct. And I'm just going to guess and check. I don't know if I'm ever going to get to 270. So in your calculator, like just rip through some of these. 3 to the power of 2, wrong. 3 to the power of 3, wrong. 3 to the power of 4, wrong. 3 to the power of 5, wrong. 3 to the power of 6, wrong. And I'm past 270. So there's definitely no way I'm changing 270 to be 3 to the power of something. It's not going to work. So instead, what you're going to have to do now is you're going to have to take that 270 and you're going to have to split it up into two different numbers. One of which can be anything. The other one has to be from my list of 3 to the power of something. So that I can change that one to be 3 to the power of something. So for instance, 270 could split up to be 10 times 27. And then 27 could change to be 3 to the power of something. They also make it a little easy for you by showing you this coefficient. And hopefully you recognize that's the same one, right? So I changed this to be 10 times 3 to the power of something. Now I can change this to be 10 times 3 to the power of something.
So if it ever has a coefficient, you kind of just want to have a coefficient on the other side too.
That's how I would do it. The other way.
Would you be allowed to divide that 10 on
Yeah.
the other side?
Yeah, so the other way would be to do this. I mean, to each their own, right? I think what a lot of people would do is they'd start immediately trying to make this 3 to the power of something and it wouldn't work out. That's not good. That's so bad. The other option is to get the power by itself, which would be to divide this 10 to the other side. So you then have 3 to the power of x plus 1 equals 27. And get that power isolated. Either way, it's going to work out. This way works for if you just get desperate and you're immediately trying to find 3 to the power of something. This way works if you identify, I want the power by itself first, then I'm going to change a base. If I had a choice, I would take this route. And I would try to get the power by itself first, and then try to do change of base. I find that method easier. Okay, but again, to each their own. Some people just jump immediately into change of base and then get frustrated. Cool. I now have 3 to the power of x plus 1 equals 27. I can do change of base. This is 3 to the power of x plus 1 equals 3 to the power of 3. Focus on the exponent. X plus 1 equals 3. Move the 1 over. X equals 2. I have to change out of this mode. It's not good. My computer can't keep up with it. That's going to be a problem in the future. Feeling good? Okay. Try some harder change of base stuff. We'll do these 3 and then you'll be on your own. Unless you want. No, let's just do it together. We haven't done negative exponents yet, so let's do this together before I abandon you. Okay, first one. You get that on a test question. It says solve. It's the only advice it gives you. You look where x is. You look for your variable. It's in the exponent. I see x in the exponent. That tells me I want to use my strategy like bases. Looking at this. One of them is a fraction. One of them is not a fraction. So I'm going to have to use my negative exponent rule at some point, right, to get rid of the fraction. But before I start worrying about negatives and stuff like that, I prefer to see if I can get these two things to be the same. Can I make 4 become 2 to the power of something? And can I go from big to small? And you can. That would become 2 to the power of x minus 2. Oh, this is getting bad. Equals 1 over 2 to the power of 2. I don't know how slow it is on there, but it is very slow on my computer. So at least I know it's like, okay, they're both going to end up base 2. That's good. To get rid of the fraction, I use my negative exponent rule. So this will become, left side doesn't change. Right side is now 2 to the power of negative 2. I got rid of the fraction, but it became a negative exponent. Right? Fraction's gone, exponent changed to negative. To the power of 2x plus 1. That's now like base. I have an exponent of an exponent, so use that rule, multiply that in, and I now have 2 to the power of x minus 2 equals 2 to the power of negative 4x minus 1. Oh, sorry, negative 2. So I've got negative exponent rule, exponent of an exponent rule. I finally got myself like bases. These things are now irrelevant. I just have to make those exponents equal each other. That's x minus 2 equals negative 4x minus 2. This is linear, right? To the power 1. Move all of your x's to one side. Then move all of your numbers to the other side. I'm going to start with moving the x's. I'm going to move the 4x by adding 4x because that's the opposite of minus 4x. X plus 4x is 5x. It's back. 5x minus 2 equals negative 2. Then I can start to move numbers to the other side. I'm going to add 2 to both sides. That gives me 5x equals 0. Divide by 5. I get x equals 0. All that work to get to x equals 0. Yep, that's fine.
Okay.
Yeah, so if you wanted to make it 2 to the negative 1, like if you went 1 over 2 to the negative 1, yeah, that works. I just prefer to get rid of fractions, but you could turn it into fractions. Yeah, that works. Okay. All right. Let's try number 2. So again, it's like, look at that. First thing I'm going to do, I'm going to move this over so that the power is by itself. So I have 4 to the power of 2x plus 3 equals 1 over 2. Why not? Now, X is in the exponent, right? Like bases is my strategy. I want to go from big to small. That means I want 4 to become 2. And then I can deal with the whole fraction thing. To turn 4 into 2, I would make it 2 squared. To the power of 2x plus 3 equals 1 over 2. Then I can try to get rid of my fraction by using my negative exponent rule. Right? But notice that I first went to see if I could change it to become 2. Then I'm like, all right, this is not base 2 though. This is 1 over 2. To make it base 2, I'm going to use my negative exponent rule. So it becomes this. 2 to the power of 4x plus 6. I'm just going to do my exponent on an exponent rule over there. I'm going to multiply that in. Equals 2 to the negative 1. This was 2 to the power 1. I moved the power to the other side, made the exponent negative 1. I did 2 steps in one there. You're good with that? Left side I multiplied in. Right side I did negative exponent. Yeah? Like bases go away. I got 4x plus 6 equals negative 1. Get all your x's on one side. They are. They're on the left. Start moving numbers to the other side. Subtract 6 from both sides. That's 4x equals negative 7. And then divide by 4. X equals negative 7 over 4.
How do you know when the change is a fraction?
If you put 1.75, negative 1.75, you're not wrong. You'll see your answers are like 99% of the time going to be fractions, except for those numeric response questions. And then we'll probably do decimal answers. Or word problems. Word problems usually go as decimals too. Both are right though. All right. The last one. Looking at that guy. I got 3 powers now. So I got 3 to the power of something, 9 to the power of something, 81 to the power of something. I notice that my letter is in my exponent. That means I want like bases. I'm going to go big to small. So I'm going to try to make everything base 3. Because that's the smallest base I currently see. After some guessing and checking, I notice it works. 9 is 3 squared. 81 is... Whoa, it's all over the map now. 81 is 3 to the power of 4. You're going to have to give me a second. I don't know if this computer is going to recover.
What happened?
It's just overloaded. It's just trying to work too hard, apparently. Yeah. There we go. 3 and 81 can all become 3 to the power of something. So this first one is staying the exact same. 3 to the power of m minus 6. Divided by, second one is 3 squared. The power of m minus 1. Sorry, 5m minus 1. And the right side is 3 to the power of 4. To the power of m. Gorgeous. If you get stuck on a math question like this, which I think most people at this point, if I left you alone, would be stuck, do something that you know how to do. So for instance, like I know I can multiply this thing, right? So let's do that, right? Like, do something you know how to do. I mean, that's not usually going to hurt the situation. So let's take this, let's multiply it in. So I now have 3 to the power of m minus 6 divided by 10m minus 2. It's 3 to the power of 10m minus 2. Equals 3 to the power of, I know how to multiply this thing in as well, so let's do that. 3 to the power of 4. Like I say, if you do something you know how to do, it shouldn't hurt the situation. Usually, it's going to help the situation. Not always, but usually. That did help our scenario. The reason it helped our scenario is I now want to focus on this to make it just 3 to the power of something. And we actually do know another exponent law with fractions. The exponent law with fractions is subtract the exponents, right? If you have same base, subtract the exponents. You're used to seeing it very basic. I'm going to put it up on the board because I don't trust this TV. You're used to seeing it like this. Right? Subtract the exponent. 2 minus 5 is negative 3. Just because it's bigger doesn't mean that rule doesn't work. Alright, so subtract the exponents. Take that top one, subtract the bottom one. That will give you, just be careful when you're doing that. If I had m minus 10m, that would be negative 9m. If I had negative 6 minus negative 2, because I'm subtracting, right? That would become negative 4. Right? Negative 6 minus negative 2. Minusing a negative makes it positive, right? So it's like negative 6 plus 2. Equals 3 to the power of 4m. I suspect, if that was a test question, most people would have negative 9m minus 8. Right? And that's because you just went negative 6 and then negative 2. But it's minus negative 2. You've got like bases. 3's are gone. You got negative 9m minus 4 equals 4m. You do some magic. You get negative 4 over 13.